Hi everyone, welcome back to another video, and in today's video I'm going to be talking about the photoelectric effect. Okay, so the photoelectric effect is quite a famous effect or quite a famous phenomenon because, well, Einstein did win a Nobel Prize for this one. So yeah, it's quite famous, right? So photoelectric effect provides a very instrumental proof for the particle nature of electromagnetic radiation. Okay, so we've been talking about this dual behavior of electromagnetic radiation since two videos now, and we have discussed how scientists were in a turmoil as to what is light. Is it a wave? Is it a particle? What is it? Okay, so what provides an instrumental proof for wave nature of light is the interference. Interference is something which only waves do, and electromagnetic radiations were doing that. Okay, so scientists were quite convinced that okay, light is a wave. Okay, but then this effect comes into existence, and then scientists are again very confused as to what is it. Is it a wave? Is it a particle? Because this provides a proof of light being a particle and not a wave. Okay, or light having particles. Okay, so all right, whenever I say light I mean electromagnetic radiation. Okay, so just write it somewhere because I might say light once and electromagnetic radiations after that, so just don't get confused. All right, so just before starting, a small analogy and then we'll begin. So whenever we have, let's say we have two balls, okay, A and B, and these two balls are coming in direction of each other. They're coming like head on in direction with each in each other. Okay, so what happens next is called a collision. Okay, these two balls are going to collide like this. All right, and then the first ball is going to retract its older path and the second ball is going to retract its older path like this. Okay, A is going to go this way and B is going to go this way, and that is what a collision looks like. Okay, collision basically happens only between particles. Waves don't do collision, right? That's quite understandable, है ना? Collision में होता क्या है exactly? One of the particle is going to transfer its energy to the other one, and the first is going to transfer its energy to the other one, and that's what happens in collision. Collision can be elastic and inelastic depending upon the conservation or non-conservation of energy, which is your physics, and I'm not going to go there. Okay, my point being that collision happens only between particles. Okay, and collision में there's a transfer of energy which takes place. Okay, now let's move on to what happens in photoelectric effect. Okay, now a very famous scientist called Henry Hertz did a very famous experiment. Okay, what experiment he did was that he took a metal surface or a metal. He took a metal. Okay, and what metal he took is something which you are going to read on your own because you should do that. And he took this metal surface and he shined some light onto the surface of this metal. Okay, this is a light, and light of a certain frequency. I am going to tell why I'm talking, why I'm saying this certain frequency. Okay, and what is the meaning of that. But he shone the light of a certain frequency onto the surface of the metal. Okay, what did he see was that electrons were ejected out of the metal surface. Okay, so first question is, why are electrons being ejected out of the metal surface? Okay, and this answer to the question ki why are electrons being ejected could be only answered if we assume that light is having particles. Okay, so let's say light is having particles. Okay, and these particles, one particle is called quanta. Okay, and one particle has the energy equal to h nu. As discussed already, h nu is the basic amount of energy that one particle of light has. Okay, and this particle this energy is the basic energy of of any particle. And if there are two particles, the energy will be 2 h nu. If there are three, there will be 3 h nu. 20 means 20 h nu. Of course, there cannot be half a particle. Okay, so the energy can never be 2.5 h nu or something 0.5 h nu because that is not possible. So fractional energies are not allowed. Okay, so light is in form of, the energy of light is in form of packets of energy, and one of the packet is called quanta. And now this packet, okay, of energy is going to interact with the electron, and the packet, the energy packet, okay, that has energy, right? That energy packet is going to transfer its energy to this electron, and that will make the electron to eject out of the metal surface. Is it clear? Is it clear why a photoelectric effect provides a proof as to why light is actually having particle nature? Of course, because if we don't assume this particle nature to be there, then what is the collision happening? Okay, there's a collision between the quanta of light, okay, and the electron, and this collision results into the ejection of the electron from the metal surface, because there's a transfer of energy between the energy particle and the electron. Okay, now this electron, how is it there onto a metal surface? So this atom looks like this. We have a nucleus which has protons and neutrons, and we have electron which is revolving around the nucleus. Clear? Now this इलेक्ट्रॉन इज बाउंड टू इट्स एटम विद सर्टेन एनर्जी. अगर ये बाउंड नहीं होता तो इलेक्ट्रॉन हवा में कहीं भी घूम रहा होता है ना, पर ऐसा नहीं होता है. देयर इज अ न्यूक्लियस एंड देयर इज इलेक्ट्रॉन एंड इलेक्ट्रॉन इज रिवॉल्विंग अराउंड द न्यूक्लियस. ठीक है, और एक सर्टेन एनर्जी है जो इस इलेक्ट्रॉन को कहीं और जाने नहीं दे रही है. दिस इलेक्ट्रोस्टैटिक एनर्जी, और देयर आर सर्टेन अदर एनर्जीज एज वेल which will be starting later, but for you there's a certain electrostatic force which is holding this electron close to the nucleus and it is not letting it go elsewhere. Clear? So now whatever light or whatever energy you're providing, light has energy है ना, light has energy equal to h nu, और जितने भी क्वांटा हैं उसके मतलब अगर let's say 150 क्वांटा है तो 150 h nu will be the energy. Okay, so this quanta of light, of course one quanta is going to interact with one electron. ठीक है, ऐसा नहीं है कि चार will interact with one and will result in rejection. No, this one quanta of light energy will be interacting with this one electron, right? And this one quanta should be having enough energy कि वो electron अपने जो जिस energy से वो bound है एटलीस्ट उसको पार करके बाहर आ पाए. ठीक है, बिकॉज अगर वो तुम उससे कम एनर्जी प्रोवाइड करोगे तो इलेक्ट्रॉन बाउंडेशन से ही बाहर नहीं आ पाएगा ना. दिस इलेक्ट्रोस्टैटिक फोर्स विच इज होल्डिंग द इलेक्ट्रॉन इनटू इनसाइड द एटम, वी नीड टू प्रोवाइड एनर्जी विच इज़ हायर देन दैट एटलीस्ट. ठीक है, अगर उससे ज़्यादा प्रोवाइड करेंगे तो ऑफकोर्स एनर्जी तो इलेक्ट्रॉन तो डेफिनेटली बाहर आ ही जाएगा, बल्कि बाहर आएगा तो उसके बाद एक्सेस एनर्जी होगी. ठीक है, एंड इफ द इलेक्ट्रॉन इज हैविंग एक्सेस एनर्जी, इलेक्ट्रॉन इज नॉट गोइंग टू डांस, राइट? इलेक्ट्रॉन एक्सेस एनर्जी का क्या करेगा? ऑफकोर्स दैट एनर्जी इज गोइंग टू बी ट्रांसफर लाइक कन्वर्टेड इनटू काइनेटिक एनर्जी एंड इलेक्ट्रॉन विल जस्ट बी इजेक्टेड आउट विद अ हायर velocity. Clear? So my point being that we need to provide a certain basic energy to this electron to be just ejected out. ठीक है, और उससे कम प्रोवाइड करेंगे तो ऐसा नहीं होगा, photoelectric effect will not take place. Okay, so we need to provide this basic energy at least, और उससे ज़्यादा प्रोवाइड करेंगे तो that's well and good. ठीक है, so let's say this electron is ejecting at blue light. Blue light is having certain frequency. ठीक है, and we do not have blue light. Let's say we only have red light. Okay, so अभी तक हमें इतना तो पता है कि red light has a frequency which is lower and hence energy is lower, and blue light has a frequency which is higher, hence energy is higher. ठीक है, so this electron is ejected only with the help of blue radiation. ठीक है, तो ब्लू हमारे पास नहीं है तो हम रेड अगर शाइन करेंगे तो क्या इलेक्ट्रॉन इजेक्ट होगा? नहीं. द इलेक्ट्रॉन इज नॉट गोइंग टू बी इजेक्टेड बिकॉज दैट अमाउंट ऑफ एनर्जी विच द रेड लाइट हैज़ इज नॉट द राइट अमाउंट. वी नीड द बेसिक अमाउंट, वी नीड द ब्लू लाइट एटलीस्ट. अगर ब्लू लाइट के बाद वी हैव यूवी ऑल्सो, वी हैव एक्सरे ऑल्सो, ऑल दीज आर हैविंग एनर्जी हायर देन दैट ऑफ ब्लू, है ना. तो अगर हम इनको प्रोवाइड करेंगे तो डेफिनेटली फोटो इलेक्ट्रिक इफेक्ट विल हैपन बिकॉज तुमने बेसिक एनर्जी प्रोवाइड कर दी और उसके बाद एक्सेस प्रोवाइड कर दी, और एक्सेस इज ऑलवेज गुड, है ना. So that excess energy will not only result into ejection of electron but also with a higher kinetic energy the electron will be ejected, है ना. बट अगर तुम रेड प्रोवाइड करोगे तो तुम्हारे पास बेसिक एनर्जी नहीं है ना, सो इलेक्ट्रॉन विल डेफिनेटली नॉट बी इवन ejected, right? So that is why we need a basic minimum energy for the electron to be ejected, and for every metal surface that boundation energy is different, so we need a different threshold or basic energy for every metal surface. So ये जो basic minimum energy है इसको हम बोलते हैं threshold energy or threshold frequency, or we also call it work function sometimes. And then जो भी excess energy होती है that gets converted into the kinetic energy. ठीक है, so if I write whatever I have just said is what in mathematical equation, so the energy is h nu of light you're providing a certain amount of light. तुम एक जो लाइट शाइन कर रहे हो मेटल सर्फेस पे उसकी एनर्जी है h nu. ठीक है, now this h nu has two works. This will perform two functions. First one is the ejection of electron, just the mere ejection of electron. उसको उसके एटम से जस्ट बाहर निकालने की एनर्जी, उस बेसिक एनर्जी को हम बोलेंगे h nu नॉट. वो एक बेसिक एनर्जी, उतनी तो चाहिए ही चाहिए, उसके बाद अगर कुछ नहीं भी होगा तो चलेगा. ठीक है, बट उतनी तो चाहिए ही चाहिए. सो दिस इज कॉल्ड द वर्क फंक्शन. प्लस अगर हमारे पास एनर्जी ज़्यादा है, ठीक है, तो दैट गेट्स कन्वर्टेड इनटू द काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन, राइट. सो वी कैन से एनर्जी इज इक्वल टू एनर्जी नॉट और द just the amount of energy plus the kinetic energy. और एनर्जी का अगर मैं फॉर्मूला लगा दूँ तो ये क्या हो जाएगा, एच न्यू इज इक्वल टू एच न्यू नॉट प्लस द काइनेटिक एनर्जी विच इज़ हाफ एम वी स्क्वायर. काइनेटिक एनर्जी का फॉर्मूला होता है हाफ एम वी स्क्वायर, वेर एम इज द मास ऑफ द इलेक्ट्रॉन विच इज इजेक्टेड एंड वी इज द वेलोसिटी विद विच इट इज इजेक्टेड. ओके, इज दिस क्लियर? ऑल राइट. Okay, so there are certain factors that we need to also consider. ठीक है, first factor is that if you are providing the right amount of energy, as I already said, तुम्हें basic energy provide करनी ही है. If you're providing energy which is less than the basic amount, then photoelectric effect will definitely not happen. ठीक है, चाहे मैं जितनी मर्जी intensity provide कर लूँ. So this is a very important difference. What is the meaning of intensity and energy? इनमें difference क्या है? ठीक है, all right. तुमने if you drive car or if you like even if you don't drive cars, you will know that there are sometimes the beam is called high beam. जो भी तुम्हारे सामने गाड़ी होती है, the light is very very bright and it's called high beam, है ना. So that's very very intense, that's very very bright. Okay, the only point is कि वो बहुत ज़्यादा bright होती है. alright, so that is called the high beam and that is highly intense कह सकते हैं उसको. And sometimes it's called low beam, it is not that intense, it is not that bright. ठीक है, so that is the meaning of brightness or the intensity. Second factor is energy. एनर्जी का रिलेशन सिर्फ और सिर्फ फ्रीक्वेंसी के साथ है. फ्रीक्वेंसी ज़्यादा, एनर्जी ज़्यादा, उसको कोई फर्क नहीं पड़ता ब्राइटनेस से. ठीक है, सो वेन एवर फोटो इलेक्ट्रिक इफेक्ट हैपन्स वी हैव टू क्वेश्चंस. फर्स्ट थिंग इज whether or not photoelectric effect happens, which means whether or not the electron will be ejected or not. ठीक है, that question is going to be answered only by the energy. अगर बेसिक मिनिमम एनर्जी है, अगर बेसिक मिनिमम फ्रीक्वेंसी है, तो ही इलेक्ट्रॉन रिजेक्ट होगा, वरना होगा ही नहीं. ठीक है, सेकेंड क्वेश्चन इज, ठीक है, विच कम्स आफ्टर द फर्स्ट क्वेश्चन, कि मान लो इलेक्ट्रॉन रिजेक्ट हो जाता है, मतलब मान लो तुम्हारी फ्रीक्वेंसी सही है, यू आर प्रोवाइडिंग द राइट अमाउंट ऑफ फ्रीक्वेंसी, देन व्हाट, तो फिर कितने इलेक्ट्रॉन रिजेक्ट होंगे. नाउ दैट डिपेंड्स अपॉन द इंटेंसिटी. ठीक है, नाउ इंटेंसिटी इफ गोइंग टू बी हाई, इंटेंसिटी बेसिकली मीन्स नंबर ऑफ क्वांटा. एज आई ऑलरेडी सेड, एक क्वांटा एक इलेक्ट्रॉन से इंटरैक्ट करेगा तो एक क्वांटा एक इलेक्ट्रॉन को बाहर निकालेगा, दो को बाहर निकालेंगे तो 100 को बाहर निकालेंगे. सो ऑफ कोर्स हायर नंबर ऑफ क्वांटा विल रिजल्ट इन हायर नंबर ऑफ इलेक्ट्रॉन रिजेक्टेड, हेंस हायर फोटोइलेक्ट्रिक इफेक्ट. राइट, सो नाउ वी कैन से कि ठीक है, फर्स्ट क्वेश्चन इज वेदर और नॉट द इफेक्ट हैपन्स, दैट इज आंसर्ड बाय फ्रीक्वेंसी ओनली. फ्रीक्वेंसी सही होगी तो होगा, वरना नहीं होगा. ठीक है, वंस इट इज देयर, ओके, द इफेक्ट इज हैपनिंग. सेकेंड क्वेश्चन is whether how much will it happen or how many electrons are going to be ejected, that is depending on the intensity. So higher intensity of the right light of the right frequency, ठीक है, means higher electrons ejected. ठीक है, अब इलेक्ट्रॉन्स की काइनेटिक एनर्जी किस पे डिपेंड करती है? डज इट डिपेंड अपॉन इंटेंसिटी और डज इट डिपेंड अपॉन एनर्जी? ऑफ कोर्स इट डिपेंड्स अपॉन द फ्रीक्वेंसी. राइट, फ्रीक्वेंसी जो है वो एनर्जी की डायरेक्टली प्रोपोर्शनल है ना. सो इफ़ यू आर प्रोवाइडिंग द राइट फ्रीक्वेंसी विच मीन्स यू आर प्रोवाइडिंग द राइट एनर्जी. ठीक है, एनर्जी अगर तुमने राइट प्रोवाइड कर दी, जो एक्सेस एनर्जी होगी, दैट एक्सेस एनर्जी इज द एनर्जी ना विच गेट्स कन्वर्टेड इनटू काइनेटिक एनर्जी. राइट, सो दिस एक्सेस एनर्जी which gets converted into kinetic energy is actually the part of the total like energy that you provided. So energy के सारे जो factors हैं that will only depend upon the frequency and intensity has no role there. Intensity basically only means कितना bright है या कितने quanta है. ठीक है, is it clear? So this was the basic theory of the photoelectric effect. You might get certain graphs, okay, between kinetic energy versus frequency, kinetic energy versus versus intensity. All these are different graphs which you should try understanding those graphs, and I think those are not there in NCERT, but if you search a little more, you will definitely find them in different other books. Okay, so this is what is the meaning of photoelectric effect and why the frequency of light is the key factor, okay, for it to happen. It's, so as I said, the first question is whether or not it happens, that is answered by frequency. Second is happens, तो कितना happens, that is answered by the intensity. Okay, and I hope this much is clear to you. This is the meaning of photoelectric effect, and only when we assume that light is made up of particles called quanta can we answer the reason of photoelectric effect. That is why it provides an instrumental proof for the particle nature of light, right? So I hope you understood what is the meaning of photoelectric effect, and this formula is used in a lot of numericals, and nu हमें पता है frequency होती है which is in per second or hertz. H is the Planck's constant and half mv square is the kinetic energy. So we can definitely use this formula to solve a lot of questions, and we will do that in the next coming videos. So I hope you do like the video. If you do that, then do press the like button, share it with your friends, and thank you so much for watching.